As we continue in our series of diagnosis of diabetes mellitus, in part 2 we have seen oral glucose tolerance test, and in this session we are continuing with the glucose oxidase method. So in this session we are going to cover glucose oxidase method and hexokinase method of glucose determination. Because it is always important to determine glucose in our laboratories to rule out this diabetes. So this is the role of the laboratory, to always ensure they give right results using these methods. And today in our discussion we want to begin with the glucose oxidase method, which we call, abbreviate it as GOD. Abbreviate it as GOD. Glucose oxidase method. And under this method, it uses the principle of this method. It works under the principle whereby if you have glucose in your blood sample, it reacts with atmospheric oxygen. Reacts with atmospheric oxygen in the presence of glucose oxidase to form gluconic acid. To form gluconic acid plus hydrogen peroxide. So we are seeing glucose oxidase, it catalyzes. The term here we use is catalyzes. It catalyzes the oxidation. So glucose oxidase method, glucose oxidase enzyme catalyzes the oxidation of glucose in the presence of atmospheric oxygen to form gluconic acid and hydrogen peroxide. And this hydrogen peroxide, which is formed during the oxidation reaction, it is converted by peroxidase. So we see peroxidase enzyme catalyzing the conversion of this hydrogen peroxide to water and nascent oxygen. This is called nascent oxygen. So this reaction is catalyzed by peroxidase enzyme, which catalyzes the conversion or the breakdown of hydrogen peroxide to water and nascent oxygen. And in this reaction, we are interested with the nascent oxygen, that whenever we have this nascent oxygen, it reacts with the chromogen. And chromogens we normally use, it is like 4-aminophenazone, whereby we add a chromogen like 4-aminophenazone. A chromogen means it is providing the color. And when it reacts with nascent oxygen, we form a pink colored complex. Form a pink colored complex. And this pink colored complex, which is formed after addition of the chromogen or nascent oxygen, it is always directly proportional. It is directly proportional to amount of glucose in sample. So the more the pink color formed, it means the more the glucose was in the blood sample. And this one is determined, it is determined colorimetrically. It is determined colorimetrically at 540 nanometer wavelength, and the intensity is directly proportional. So this is the principle of glucose oxidase method when we are determining this glucose in venous blood, collected in fluoridated bottle. The samples we use, we collect them in the sodium fluoride. So the anticoagulant used is sodium fluoride, whereby sodium fluoridated, they are gray, they have a gray top, and they are antiglycolytic, whereby they act by inhibiting enolase. Inhibit enolase enzyme, which participates in the conversion of adding an eno group to form phosphoenolpyruvate. So we collect it in a gray top, and then we can use it to determine. So the principle we have seen, glucose oxidase catalyzing the oxidation of glucose in presence of atmospheric oxygen to form gluconic acid plus hydrogen peroxide. And this hydrogen peroxide is catalyzed by peroxidase to form water and nascent oxygen. And this nascent oxygen reacts with a chromogen to form a pink colored complex, whose intensity is directly proportional to the amount of glucose in the sample, determined colorimetrically at 540 nanometer wavelength. So this is the principle we can talk about. And the method, in the method, we normally assemble the requirements. We assemble the requirements which we need to use, that is the sample, the blood sample. We shall need a control, we shall need a standard, we shall need a blank, we shall need a timer, and a colorimeter, and test tubes. So when we assemble them, when we assemble these in place, we label the tubes as below. We label the tubes whereby we shall have the blank, we shall have the test, the control, and the standard. These are the tubes we shall have this test, and here we shall have glucose reagent. We shall have glucose reagent. Then we shall have the test, the control, and the standard in place. But as you are going to mix, here, after assembling your requirements, you label, you switch on the colorimeter. Switch on the colorimeter, and you leave it to warm for 15 minutes. Leave to warm for 15 minutes. As it is warming, you come and pipette as follows. You pipette whereby for glucose reagent, here we are going to add 1 ml, here 1 ml, 1 ml of glucose reagent, and here 1 ml of glucose reagent. Then in the test, in the blank, we shall not put anything. Then in the test, we are going to add 10 microliters. Then in the control, we also put 10 microliters. Even in the standard, we put 10 microliters. After adding them, you mix well. Here, mixing is very important. Mix well the solution. And after mixing well, you leave it to incubate at room temperature for 10 minutes. Leave it to incubate at room temperature for 10 minutes. And after 10 minutes of incubation, you come and set the colorimeter at 540 nanometer wavelength. After setting it at this wavelength, you zero the colorimeter. Zero the colorimeter using blank solution, whereby blank solution contains glucose reagent only. Then after zeroing, you read the absorbances. Read the absorbances of the test, control, and standard. You read, but majorly we read for the test and the control. Then after reading the absorbances, you record. Record the absorbances. After recording them, we are going to apply Beer-Lambert's law, whereby we are going to use Beer-Lambert's equation. We're going to use Beer-Lambert's equation to calculate the concentration. So we calculate the glucose concentration of the test and control using Beer-Lambert's equation, which states that concentration of glucose is equal to, in the test, is equal to absorbance of the test divided by absorbance of the standard times the concentration of the standard. So this is the formula we use to calculate both the test and the control, whereby if it is control, it will be absorbance of the control of absorbance of the standard times the concentration of the standard. After that, after we have calculated, we record. We report the results either in millimoles per liter, depending on how the colorimeter is, depending on the units of the standard. It depends on the units of the standard. It can either be millimoles per liter or milligrams per deciliter. The reference range, I told you the fasting is 3.6 to 6.0 millimole per liter. Then for random, it is 4.5 to 7.8 millimole per liter. That is for random. Whenever you are asked this question, you should always include the QC, whereby the quality control is the key in the laboratory. So we should quality control, and quality control is that linearity. You check on the linearity, which should be up to 200 milligrams per deciliter, and to consider these results, the control should pass. The control must pass for you to consider these results. So this is the QC you can do on this test. So that is basically about how we can measure glucose levels using glucose oxidase method. This question, please, my dear students, always remember to know it in case they can be asked it in theory or in practical, so you are able to pass it. And also, when we are in the field, we are able to apply this knowledge. Lastly, we want to look at hexokinase method, whereby this hexokinase method want to look at hexokinase. And this hexokinase method, it utilizes this enzyme known as hexokinase, whereby the principle of this test, this hexokinase is found in skeletal muscles. And in skeletal muscles, this hexokinase enzyme, it catalyzes the phosphorylation, whereby if I have glucose in my sample, which I have collected in the lab, hexokinase will catalyze its phosphorylation by adding ATP and hydrolyzing it into ADP plus phosphate inorganic, whereby it is going to add a phosphate group at carbon number 6 of glucose to form glucose 6-phosphate. So what is the hexokinase doing? It is catalyzing the phosphorylation. Phosphorylation means it is adding a phosphate group at carbon number 6 of glucose to form glucose 6-phosphate. That is point number 1. Point number 2 says that when I have glucose 6-phosphate, it is reduced, whereby we need an enzyme known as glucose 6-phosphate dehydrogenase. 6-phosphate dehydrogenase enzyme, whereby we see it being reduced by removal of hydrogen in the form of NAD. That when we have NAD plus, we have form NADH. From NADH, and this one produces a compound known as 6-phosphogluconolactone. Phosphogluconolactone is formed whereby glucose 6-phosphate dehydrogenase, it catalyzes the reduction of glucose 6-phosphate to 6-phosphogluconolactone. And this one is a kinetic method whereby the rate of formation measures the rate of formation of NADH. The rate of formation of NADH is determined, or it is continuously monitored. At 340 nanometer wavelength spectrophotometrically. This method, being kinetic, it uses spectrophotometer. So we use spectrophotometer. And the intensity or the rate of reduction, we are measuring the rate or the change. The rate of formation is going to be directly proportional. Meaning the more the glucose, the more we shall form this, and it will be directly proportional to the amount of glucose. Amount of glucose in the sample. And we have said this is kinetic method. In kinetic method, you continuously monitor. You don't wait for the product to be formed, but you continuously monitor at interval. So this is basically what we have discussed in this session, whereby you have looked at glucose oxidase method and hexokinase method. Thank you for always being with us in this channel. Always remember to comment, liking the video, and above all, subscribe if you haven't subscribed. Thank you so much.